Hello again. In this video we're going to start looking at how to write a monitor class. A monitor class is internally synchronized. It does everything which is necessary to protect its internal data against data races. So this means that users of the class don't need to worry about it. In Java you can get this just by declaring your class as synchronized. In C# and C++ you have to do some more work. As an example, we're going to go back to our bank account transfer. We have some money in this account and we want to transfer it to that account. We want to do this as a transaction, so other code will see that either all the money is here or all the money is here. They won't see anything that happens in between. We're going to use this very simplistic bank class. Real banking software is slightly more complicated than this. We have a member function which will debit the account, take money out of it, one which will credit an account by putting money into it, and one which will display the balance, how much money is in that account. The obvious way to do this is to add a mutex as a private data member to the class, and then each member function which will access shared data or data which could be shared will lock a mutex first. So our code will look like this. We have our bank class which has a mutex as a private data member and some data which may need to be protected against concurrent access. The member functions will lock the mutex before doing anything. This is just an example, so I'm just going to print out a message. And then when the member function returns, the lockguard destructor will unlock the mutex. In the main function, we create an object of this class, and then we start a thread which will perform the transaction by calling the member functions. We need to capture the bank object by reference because it cannot be copied. It has a mutex as a data member which is not copyable, so the default copy constructor is deleted. We could write one if we wanted to, but it's not worth it for this example. And there we are. And this will work after a fashion, but there are quite a few drawbacks with it. It may be that member functions need to call other member functions. So we have a situation where a member function locks a mutex, and then without unlocking the mutex, it calls another member function which will lock the same mutex. So we have multiple locks of the same mutex, and as you should remember, that can cause deadlock. If we're doing transactions like we did in the example, we may have to call a number of member functions, and each of those member functions will lock the mutex, then unlock it. So that will cause a lot of locking and unlocking operations, which will slow down the program. It can also lead to a race condition if other threads can access the data while the mutex is not locked. And if these accesses are conflicting, then we have a data race. And one more problem, which is not related to threading directly. This will only really work if we're writing a new class. If we have an existing class, we need to modify it to add the mutex member and the locking and unlocking code. We may need to run all our tests again, which will add to the development time. And it may be that we cannot modify the class, either it's been frozen or we don't have access to the source code. The slightly better solution is to move the mutex and the locking code out of the class and into a wrapper. We have a class which has the mutex as a member and an object of the bank class, and then this will have the same interface as the bank class. The public member functions will call the member function of the bank with the same argument, but they lock the mutex first. Our code will now look like this. We've moved the mutex and the locking and unlocking code out of the bank class. We now have this monitor class which has the mutex and the bank object as members. The member functions will lock the mutex and then forward the call to the corresponding member function of the bank class by calling the same member function with the same arguments. In the main function we now create a bank monitor object instead of the bank, but the rest of the code is the same. Okay. So we now have a solution that will work with any type. We can use it with classes which were not designed for multi-threading, perhaps an old C or C++ library. and we do not need to make any modifications to the class. However, we still have these problems with transactions. We're still performing all this locking to slow things down. We still have the possibility of deadlock if member functions try to lock the same mutex more than once. And we still have interruptions by other threads, which can cause race conditions and data races. In the next video, we'll look at a solution which addresses these problems, but that's all for now. I'll see you next time, but until then, keep coding.